All right, welcome. Today, we're going to tackle a mystery that sounds, well, almost too simple. It's one of those things you've probably felt a million times but never really stopped to ask why. But this one question about motion, it takes us from something as simple as a dizzy spell right to the very edge of modern physics and what reality itself is actually made of. So here's the puzzle, right? You've got astronauts on the International Space Station hurtling through space at something like 17,000 miles per hour, and they feel absolutely nothing. It's just floating. But then you spin around in an office chair and bam, you instantly know you're moving. You feel it in your gut. So how can one kind of speed be totally undetectable while the other is so, well, absolute? What is going on here? Let's figure this out. Okay, so to get to the bottom of this, we first got to break down what we're actually talking about. We're dealing with two totally different kinds of speed here. And believe me, the difference between them, well, it's everything. All right, let's break this down. On the one hand, you've got linear velocity. Think about being on a super smooth train. As long as it's moving in a straight line at a steady speed, it just feels like you're sitting still. It's what we call a state of being. It's totally relative. The only way you even know you're moving is by looking at the scenery flying by. But then you've got rotational velocity, and that's a whole different beast. It's actually a state of constant acceleration. See, even if you're spinning at a steady speed, your direction is changing every single nanosecond. And your body? Oh, it for sure feels that constant change. So the first piece of our puzzle is this. Why is that straight line speed so sneaky? Why is it completely unfeelable? Well, the answer has everything to do with the actual path you're taking through the universe. And that brings us to this really cool idea called a geodesic. Now, I know, it sounds a little technical, but it's actually super simple. Just think of it as the universe's default path. It's the path of least resistance, the straightest possible line an object can take through the four-dimensional fabric of spacetime. So when you're moving at a constant speed in a straight line, I don't care if you're in a car, a plane, or a spaceship, you are just cruising along a geodesic. And here's the key. Every single atom in your body, from your head to your toes, is moving together in perfect harmony. There's no internal stress, no forces tugging one part of you differently from another. There's literally nothing to feel. You're just coasting on the universe's invisible highway. Okay, so if moving in a straight line is just coasting, then what's going on with rotation? Well, it's the total opposite. It's not a gentle ride at all. It's a constant, nonstop fight. It's you struggling against that natural, easy path. And here is where that feeling comes from. When you spin, your body's inertia is desperately trying to keep you moving in a straight line. It wants to follow that nice, easy geodesic. But the spin itself is like a rope, constantly yanking you away from that straight path, forcing you to turn. And that feeling, that tension between where your body wants to go and where it's being forced to go, that's exactly what we feel as G-force or inertia. But wait a minute, this brings us to the real core of the mystery. Imagine you're floating in a completely empty universe. I mean, nothing. No stars, no planets, just you. And you start to spin. You would still feel your arms pull outwards. But what are you pushing against? If there's nothing else there, what are you spinning relative to? What's providing that pushback? Well, the answer is, honestly, it's one of the most mind-blowing ideas in all of physics. You're not pushing against nothing. You're pushing against the fabric of the universe itself. What this tells us is that spacetime isn't just empty space. It's not just a void where things happen. It's a real physical thing, a kind of fabric. You know, Newton had an idea he called absolute space, and Einstein later updated it with his concept of the metric field. But the easiest way to think about it is like an invisible four-dimensional grid that fills, well, everything. And this is the solution to our whole mystery. When you're moving in a straight line, you're just sliding with the grain of this cosmic fabric. It's smooth, no resistance. But when you rotate, now you're trying to twist against the grain of space-time. The reason you feel the spin, the reason it's absolute, is because you are in a physical struggle with the fundamental structure of the universe. Okay, but that just opens up another even deeper question, doesn't it? What is this grid? What is this fabric of the universe actually made of? Well, to answer that, we have to go from the massive scale of Einstein's universe all the way down to the super weird world of quantum mechanics. So at the tiniest, most fundamental level imaginable, the universe is filled with something physicists call the quantum vacuum. You can think of it like a quantum soup. Now, for someone just sitting still, this soup is completely calm. It's cold, it's at its absolute lowest energy state. For all intents and purposes, it's invisible. But this is where it gets truly wild. There's this mind-bending idea called the Unruh Effect. And what it says is that if you accelerate, and remember, spinning is just a type of constant acceleration, you are no longer moving smoothly through that quantum soup. No, you're essentially thrashing around in it, sloshing it about, and from your perspective, as you're accelerating, that cold, empty vacuum suddenly seems to heat up. It appears to boil with a warm bath of particles and radiation.
And this is pretty much the frontier of physics right now. The leading theory is that inertia, that g-force you feel pushing you into your seat, or the way your arms feel pulled outward when you spin, it isn't just some abstract idea. It might be the very real physical pushback from the quantum vacuum, the fabric of reality itself, literally resisting your movement.
So let's just wrap this all up nice and neat. Take a look at linear velocity. Is it feelable? Nope, because it's relative. Is it accelerating? No way. It's just following that easy geodesic path. But then look at rotation. Feelable? Oh, you bet it is. Thanks to those inertial forces. It's constantly accelerating, which means it's constantly being yanked off that geodesic. And that's the whole difference in a nutshell. One is relative because you're going with the flow. The other is absolute because you're fighting the very fabric of spacetime. So yeah, the next time you spin around and feel even a little bit dizzy, just take a second and remember what you're actually feeling. It's a direct, physical interaction with the most fundamental structure of our reality. And that kind of leaves us with one last big question, doesn't it? If inertia is literally the universe pushing back on us, what else are we feeling every single day without even realizing what it is?